Greek Owl. Welcome to our strange school year. What you're going to be doing with this video is we're going to look at Chapter 1, Section 1. I have the same notes that you should have, and I've already filled mine out. That's not the typical way that I run my classroom. Usually when I do notes, we're doing notes at the same time. I'm writing, you're writing. But to save time, I've got them all filled out. I'm going to go over them. So for those people who really wish that I wouldn't talk so much, they're like, you know, I've got this. I don't need to watch everything worked out in detail. This is going to be great for you. You can just zoom through the video. For those of you who like me to go slow, like it when I pause and give you time to copy what I've just written, you like hearing the detailed explanation of how things are worked out, you're the type of person, if you didn't understand what I just said, you'll raise your hand and say, I don't get that. Can you explain that again? Well, this is good for you too, because now you can just pause the video if you want to copy something on your paper. You can rewind the video if you want to hear me say something again. And of course, if I did something that you don't understand and I didn't explain it, you can always reach out to me through Remind or email or Google Classroom or whatever. So, here we go with Section 1.1. This just kind of gets you acquainted with the coordinate plane. It says list everything you know. So, I wrote my quadrants in here. Remember, you're supposed to use Roman numerals when you write the names of your quadrants. Here's my x-axis, and fun fact, y is always 0 on the x-axis. So if you have any point on the x-axis, the y-coordinate is always 0. On the y-axis, any point on the y-axis, your x-coordinate in your ordered pair is always 0. And I've got these 3 points plotted and labeled in the graph. Next, we are asked to see how do I know if an ordered pair is a solution to an equation? Well, we're just going to test it. So I have 2 ordered pairs. I plugged them into the equation one at a time. So notice I plugged 4 in for y, plugged 3 in for x, and I said, you know what, I'm not really sure that they're equal. That's what we're testing right now. Are they really equal? So sure enough, when I do the math, yes. The left side is equal to the right side, which means this one is a solution. Over here, I plug this point in. Not sure if they're equal. Do the math, found out. Nope. The 2 sides aren't equal, which means no, this point is not a solution to the equation. All right, quick review on graphing. It says sketch the graph of this equation. Hopefully you can see that it's linear. Hopefully the slope and the y-intercept jump right out at you. So I've written the slope as a fraction. I've written the y-intercept. Remember, when you have a negative fraction, you can put your negative with the number in your numerator, or you can put the negative with the number in your denominator. It doesn't matter. So you plot your y-intercept on your y-axis. Now watch. I can either go down 3 over positive 1, and or I can go up 3 over negative 1. And you can see that both of those points that I use with my slope lie on that line. Next one. I really hope that you see this and you think automatically, oh, quadratic. Oh, look, it's almost the parent function that we learned about in Algebra 2. It's just been shifted down 1. So what I can do is I can think about what a parent function y equals x squared looks like and shift everything down 1. Or, if that didn't come to you, you're always welcome to make an xy table and plot your points there. All right. Moving on, piecewise functions. These are interesting. Hopefully you've had a little bit of experience with like at least plugging numbers into a piecewise function, but now I want you to be able to graph one. And it's a little bit tricky. So I have two methods. This first method is for the people who really like steps. Just give me the steps to do. Mrs. Neal, I will do the steps every single time, I promise, and I'll do them exactly the way you tell me to do them, and I'll get my answer. This one's for you. So here we go. It's a piecewise function because it contains two pieces. So basically it's saying y is equal to this piece when x is less than or equal, or no, when x is less than negative 1. However, y is equal to this piece when x is greater than or equal to negative 1. So I've color-coded them. I've made one piece pink and I've made one piece blue. And the way that I want you to do this is make an XY table. Now, this looks kind of like a confusing XY table because I've got my X column here, but I've got two Y columns. Why do I have two Y columns? Because my piecewise function has two pieces. So I've got a column for the pink piece, and I've got a column for the blue piece. And so what I'm going to do, this number right here, negative 1, this is the place where my pieces switch. So what I'm going to do in my XY table, I want to put negative 1, this number right here, I want to put it in my X column, like in the middle of my table. Put that in the middle. And then get some numbers above it, above negative 1, and get some numbers right below it. Now, what you're going to do is the numbers that are the x values that are less than negative 1, you're going to plug them in the pink piece only. So plug negative 4 into the pink piece, I get a y value of negative 4. Plug negative 3 into the pink piece, I get a y value of negative 2. Plug this in, I get a y value of 0. Now, the negative 1, I want you to go ahead, since this is where your pieces switch, I want you to go ahead and plug negative 1 into both columns. So I've plugged negative 1 into the pink piece, got a y value. Plug negative 1 into the blue piece, I got a y value. And then every x value bigger than negative 1, of course I'm going to plug into the blue piece. Y value, y value, y value. Now, plot all your points. So I'm going to, in pink, I'm going to plot negative 4, comma, negative 4. I'm going to plot negative 3, negative 2, and so on and so on. This one, you're going to be, this one right here, I'll talk about that one in a minute. Let me switch over to the blue. Ready? I'm going to plot the point negative 1, 4, negative 1, 4, and then this one, and then this one, and that's blue. So, keep in mind, this is a function. I could totally do the vertical line test on this function. Now, if I would have colored this in, if I would have colored this pink point in, right here, can you see that I would have failed the vertical line test? It wouldn't be a function anymore, but it is a function, so I have to make sure my graph reflects that. So, since the pink piece is only good for values less than but not equal to negative 1, and the blue piece is good at negative 1, I'm going to keep the blue piece filled in, and I'm going to make the pink one open at the x value point of negative 1. The pink one had a point of negative 1, comma 2. The blue one had a point of negative 1, comma 4. This is the one that I want to keep filled in. This one's going to be open. And you can see how my arrows extend because, think about this, could I plug in negative 5 to the pink equation? Absolutely. Could I plug in, I can't extend it this way. Can I plug in 0 to the pink? No, not allowed. I am not allowed to plug 0 into the pink. I can only plug 0 into the blue. So you can see which way these would extend. Okay, so again, steps for graphing a piecewise function. Notice where they split. Set up your XY table with 2 Y columns. Put the X value where they split in the middle. Get some numbers on either side and decide where, which piece you're going to plug them into. And remember to plug this one into both, because we need this here. We need it leading up to that open circle. All right, now, hopefully kind of quickly, I would like to show you, this is the quick way. This is for people who look at this and say, oh, yeah, it's piecewise. I got 2 pieces. I got a line with a positive slope. I've got a line with a negative slope. And my pieces switch when x is -1. So here's what I need you to think. This is the line, this is the piece that you should be seeing on your graph for all x's leading up to -1. This is the piece that you should be seeing on your graph for all x's equal to and greater than -1. All right, so let me show you real quickly. This is how I tend to graph a piecewise function. I'm going to graph the pink line very lightly. Here I go, pink line. 4, slope of +2. Blue line. Y-intercept is, I'm doing it very lightly. So if you had a pencil, you would be doing this very lightly. Y-intercept is 3. Slope is -1. Now, where x is -1, see this right here. Where x is -1, this is where my pieces need to switch. So think about all the places where x is -1, kind of like a vertical line. The pink is what I need to see leading up to here, which means I need to get rid of all the pink on that side. So I would get rid of all the pink on that side of the orange line. Now all I have is the pink leading up to where x is equal to -1. Now let's think about the blue. The blue is what I should see from -1 on. So from -1 on, all I should see is the blue, which means over here, I need to get rid of that. So I'm going to get rid of it. Now, I see the pink leading up to where x is -1. I see the blue leading away from where x is -1. Now, slight problem, you can't have both of these filled in. There should be like that little bit of overlap there originally, but only one of them can be filled in. So I go back to here and think, oh, look, that one's got to be open. So pink is open, blue is closed. Blue is closed. Pink is open. There we go. Pick a method that you're comfortable with. Don't just pick the quickest. Pick a method that you're comfortable with and go with it. And that's the way you should approach these problems every time. Moving on. We're going to find intercepts of an equation. So just a reminder what an x-intercept is, and remember every time your graph crosses the x-axis, y is 0. Likewise, every time your graph crosses the y-axis, x is 0. So to find x and y intercepts, we always make that, like our opposite variable, we always make that 0. Okay. Here we go. Again, I've already got these filled out, so I'm going to kind of talk through them. And if you need to pause the video to copy the notes down, I don't know, maybe you want to listen first and then pause it and copy everything down. Might make more sense to you that way. So, x and y intercepts. I started with the y. That's usually the easiest one. Doesn't matter, though. So notice that I copied my equation and I plugged 0 in everywhere there was an x. And then I did the math. This is what I got for my y-intercept. You can write it like this, or you can write it as an ordered pair. Keep in mind, if you choose to write your y-intercept as an ordered pair, this goes in the y coordinate spot. The number you put in here is whatever you plugged in to get this. So since I plugged in 0 for x, 0 has to go here. This is what I got for its corresponding y. Either way is okay to write the y-intercept. Okay. For the x-intercept, I copied my equation and I plugged 0 in for y. Now, this is quadratic. You should recognize this is quadratic. There are several ways to solve a quadratic equation. Looking at this, I'm thinking either factoring or quadratic formula. I'm going to choose factoring, definitely. So I factored it into two binomials. These multiply to make -3. These add to make +2. And then for this binomial to equal 0, x would have to be -3. For this binomial to equal 0, x would have to be +1. This graph has two x-intercepts, two distinct points. So if you want to write them as ordered pairs, that's fine. Make sure that this goes in the x spot, and whatever y you used to get this has to go in the y spot. And remember, we used 0 for y. So if you write it like in an ordered pair, make sure you get those correct. Let's see, number 1. Yes, let's jump over to number 2. Number 2, I did the y-intercept first, plugged in 0 for x, and got 0 for y. So either way is acceptable. X-intercept. Plugged 0 in for y. It's quadratic, but different than the quadratic we just did. Here I only have two terms. Both terms have a common factor of x, and they both have a negative sign. So I pulled both of those out. I pulled out the negative and an x. So pull this out of here, I'm left with +x. Pull this out of here, I'm left with +5. In order for this binomial to be 0, x would have to be -5. In order for this portion of my factored quadratic to be 0, obviously, x would have to be 0. So, writing them like this is acceptable, or putting them in ordered pairs is acceptable. Okay, I know I'm skipping number 3, just for a minute. Let's jump to number 4, because this is kind of an easy one. Y-intercept, plug in 0 for x. So this is function notation. I plug in 0 for x, plug in 0 for x, do the math, and I get the square root of 7. I'm just going to leave it as the square root of 7. If it bothers you, you can put yours as a decimal. Make sure you follow directions in my math lab, because sometimes it'll tell you to use the decimal and round, Other times it'll tell you keep it in radical form. So there's your y-intercept as an ordered pair. Okay. X-intercept, I set y equal to 0. Now, to solve this, I notice that all of this is under a radical, and I need to free it. So in order to free it, I'm going to square both sides. This is what I get. I'll move my x squared over, and then I square root both sides. Remember, when you square root both sides of an equation, you've got the positive and the negative root. And so I've got two x-intercepts, positive radical 7 and negative radical 7. And you can write them like this. You can write the intercepts like this. Or you can write them as two distinct ordered pairs. Totally up to you. All right, last one, number 3, and this one's a little tricky. First of all, for y-intercept, this is easy. Plug 0 in for x, that's what I get, all good. Now, x-intercept, plug 0 in for y. What x value is going to turn this fraction into a value of 0? So let me have you think about something for a minute. How can a fraction equal 0? Does 10 divided by 0 equal 0? If you don't know, ask your calculator. Does 0 divided by 10 equal 0? If you don't know, ask your calculator. I happen to know, and I think you learned this at some point, you cannot divide by 0. That's like one thing you can never do in math. You cannot divide by 0. So this fraction does not equal 0. What I say is whenever you try to divide by 0, boom, you just blew up. But I can take 0 divided by anything, and I'll get an answer of 0. So apply this knowledge of, in order for a fraction to be 0, my numerator has to be 0. Apply that thinking to this problem. In order for this problem, in order for this fraction to be 0, your numerator has to be 0, not your denominator. So how do you do that? Totally easy. To find our x that's going to cause this fraction to equal 0 and not blow up, focus on the numerator only. Don't look at the denominator. Numerator only. Set it equal to 0 and solve it. This value of x, right here, -7/4, when plugged in here and here, will cause this value to be 0. All right, hope that helps. And again, let me or your teacher know if you have any questions about the notes or as you're going through your homework.